Hello everyone, welcome back to another video in the LLMs related playlist. In this video, we are going to see about how you can build your own RAG from scratch without using any Langchain or Llama index or any other libraries for that matter, for example, file data. In this video, I'll show everything from scratch just by using Hugging Face and their own ecosystem. We won't use any wrapper. The idea behind building this kind of a RAG framework, that too from scratch, is that you will gain control over what is happening behind, and this will benefit you in different ways. Like you will understand what is going behind. Also, you will be able to customize it wherever you want and however you want. Now let's start with understanding about the workflow of how a RAG framework is built, and then we'll move on to the code. The architecture starts by loading the PDF, and followed by which we need to chunk the PDF file into smaller documents with the help of the character text splitter, followed by which we will be creating a vector store which will be saved locally by using PyTorch. And then once these are done, we can move into getting the input query from the user, computing the embeddings for it, and we'll retrieve the top k results based on that by using the vector store, and finally the LLM will provide the answer. Now that we have understood the workflow of how a rank framework is built, we'll now see how you can build your own RAG framework with the help of just open source LLMs and libraries without any framework. Alright? So, first step, as we all know, it is to load the file. And for this, I'm using PyMu PDF, and you can use whichever loader is you think is good. For me, in my experimentation, I have found that fits, which is PyMu PDF, is good. All right. So the first function would be to load the PDF. All you need to do is provide your PDF file path, and now what we'll do is we'll create a file or a list for the file known as contents, where first in which there is a function called open. Once we open the file, it will have the list of documents in it. We'll go through each of the pages and we'll get the text, and all we're doing is adding a slash in and then providing the content so that there will be a split among the contents. Just to make sure that there is a split, we are also adding slash in dot join of contents. What it will do is, in the contents there are list of pages content. Okay, for example, first page content, second page content, everything will be there. All of those are combined into a single string document. All right. So all we need to do is just call load PDF. Okay, we'll see that as well. Now it has loaded. I'll show you all. Okay, docs. And as you can see here, this is my dummy resume I have created for some other video. And now we have the first one, which is to load the document being ready. Again, now to see about the customization, you can load JSON, you can load CSV, you can load databases, whatever you want by yourself with customizations. For example, I added 2 slashes in here, which is not possible when we do use wrappers like Langchain, Llama index, or people who are wrapping even on top of that. For example, file data and crew AI and so on and so forth. All right. So we are just focusing on how we can customize it. The next step would be to chunk the data, right? So for this, we are having a function known as split characters, or also you can have it as chunk documents. We can put it whatever we want, right? Again, our own file, we can do whatever we want. So here, all we are doing is first, we need to create the splits. For example, in recursive character text splitter, how it happens is, I'll write it in here. For example, I have a string like this, right? Not this. Something like this, all right? So this is this splitter which we have written here is a recursive character text splitter. What it will do is it will go through the splitter. So for example, we have the chunk size at as 5 and the overlap as 2. What will happen is I'll just take Vasanth is say, okay. Vasanth is saying we'll consider this string. The list will be like, let's take first 5 letters. So it will be VASAN, and then a new one where it will be TH space IES space, and that's all. That will be the next one. And then the next one would be SAYIN, and then the next one would be G. Given that the chunk overlap is 0, if I had kept it as, we'll have it in here as chunk size is 0 and overlap is 0. Oh, sorry. Chunk size would be 5. All right. So now let's take this case where I have overlap as 2 and the same chunk size. Okay. So what will happen is the first one will remain the same, which is Vasanth. And now instead of just generating TH, it will generate SANTH, and then in this one it would be NTH space I, and then it would become something like H space IS space, and then it would become IS space SA, and then SAYNG, something like that. Okay, so this is how the split happens for chunk size is equal to 5 and overlap is equal to 3, not 2. I guess I took 3. Okay, so this would be our example for this of how things work when we are doing chunk overlapping. So what it will do is it will just make sure that the start, this is a safety function to ensure that there is text in there, not empty string. Okay, so we are checking if 0 is less than len of text, which means that is there. The end would be min of start plus split length comma len of text. So let's say the start is 0 now and split length is 5 and the len of text is something like 10. Okay, which means we can split by 5. But what if it was the length is 3 and I gave 5, so it should become 3, right? The split shouldn't happen. So that is why we have the split length. And what we'll do is we'll just take start and end here. That's all. Okay, now to change the overlap, right, you need some overlapping, which means you need to go back in your start. For example, I came from 0 to 4 in index, and then now since my overlap is 3, I need to jump from 4 to 1 if I'm not wrong, or 2. Okay, I hope you get the point. So what we are doing is we are just changing the start to split length minus overlap. Okay, so that the start will be moving on with 2 to 3 index, so it will be a difference of 5 minus 3, which is 2. It will move by 2. Okay, so that is how the split will happen. And now we'll do that as well. We'll keep it as chunk size. Okay, now it is chunk documents. And guys, these kind of documents or these kind of videos are not available over internet, so if you are like this kind of video, please let me know by tremendous amount of like and comments, which will make me know that okay, you guys like these kind of videos, and it will help me to serve you better with more videos. Okay, now the splitting documents have happened, and let's see what is there in there. Okay, so you can see, right, the split has happened and the last one alone has a very little data, but there is around 1 2 3 4 5 6 7 documents in there, and I have just kept it to 7 so that it will be very fast for us to move on to the next steps. Let's see about a simple vector database, how you can build that. we are not using files because if you want to use files from scratch, let me know in the comment section. I'll make a video on that. But using files from scratch is pretty harder than rather than without using Llama index or Langchain. So what we are doing here is we are just gonna use torch file to save it. Okay, torch file to store the vector store. Torch save vector store. That will store our vector store. Okay, so for this, the steps would be: first, compute embeddings for the document, make a embedding dictionary where the key will be the chunk and the value would be the embedding, and then save dictionary as torch file. Okay, so this is how this creation of vector store happens. And now we'll see the code. Okay, so the source function here is create vector store, which has all other functions being called inside. So first what we'll do is we'll have a simple list known as chunk embeddings, where what happens is first we'll create a sentence transformer, whatever model is chosen, and that embedder, what it will do is it will embed all the chunks. Okay, chunks comes from this one. Okay, you already created your chunks here, right? So this is your chunks. Let me rename this as well, actually. Chunks, and here also it is going to be chunks. Okay, now this is also done. And what happens is you'll go through the chunks and each chunk will be encoded and it will be stored as a tensor. Okay, so for that we need to convert it into tensor. We'll append that into this list. Okay, chunk embeddings. Then this, once this computation of embeddings is completed for all the chunks, be it 1000, 10,000, we'll call this function of store embeddings as dict, which will take two parameters with it, which is embeddings list and text list. Text list is nothing but your chunks list. Okay, so here we'll be providing our chunk embeddings and chunks. So what it will do is it will try to create chunk is to chunk embedding. This kind of a dictionary will be created, and we'll save that with the help of save embeddings.pt to pt file, which is nothing but calling a toss.save function. Okay, all you need to do is provide a dictionary and then a file path, which is just embeddings.pt. You can keep whatever you want. Okay, we'll call that. And right now for simple things, like, now we are not focusing on accuracy here, because we all know that if I use MXBAI or any other bigger model, the performance is going to be good. So right now I'm just going to take a small model, all many LM L6V2. So the process of creation of vector store is happening, and as you can see here, there is also a progress bar. Again, see, this is something you get with customization. I don't know how much customizable it is with Langchain, but here you can see, right, we can just change the progress bar. We can provide descriptions here upon our choice. Because I gave it as computing embeddings, it is there. Let's say I'm saying Vasanth embeddings. It will say Vasanth embeddings, right? So that is what I love about customizing from scratch. And also you have a better control of what is happening inside. All right, so now you have created your vector store based on the documents which are split before by using the text splitter which we created by ourselves. And then now it is time for the most important part, which is to create the retriever. All right, so again here we are going to take a single function, which is retrieve relevant docs, which is taking 4 different inputs or parameters. Okay, embedding model, your embedding path where you stored your embeddings, your query, and what amount of retrieve, like how many do you want to retrieve, how many chunks, is it 5, 4, 3, how many ever you want. All right, so what happens is first we'll create the embedder, we'll load the embeddings, and we'll get the chunks first. Okay, because we need to compute the similarity between the chunks and all, right? So just to get and it is also a dictionary, you can just index the dictionary with the help of key only, right? And chunks is the key, so that's why we are taking the keys here. All we are doing is first we are encoding the query. Okay, and then we are computing the cosine similarity. Okay, that is where the retrieval happens. So for this, first we are making sure that the top k is lesser than the number of documents there in the dictionary. For example, I have only 5 chunks and I'm saying I want to retrieve top 10. There is no point, right? There is only 5 chunks. So we are just checking the top k there, and it also ensures that there is no error coming up. All right. Both are advantages there. And here we are going through the chunks. Okay. And we are saying computing similarity is happening. What we're doing is in transformer, for sentence transformers, there is a util file, okay, util function, which has a function called cosine, which is nothing but your cosine similarity. What we are doing is simply comparing the query with the chunk embeddings. Okay, whatever embeddings is there for a respective chunk, we are comparing it, and of 0 will give you the score. Right now, all we are doing is we are appending those scores into a list. Okay, because in torch there is a function called top k, which will help us to get the index of top 5 maximum numbers or top 10 maximum number given a k. Okay, so all you need to do is, since we are going to use torch, we are going to need to convert the list into a tensor, for which we'll call torch.tensor of scores, and we'll get the top k chunk indices with the help of torch.top k function, where you'll provide the scores as well as your top k value, where we are calling the indices and we are converting it into a list. Okay, now you have the top k chunk indices. For example, I have 7 documents. Top 3 document indexes are ready, but I need the top k chunks, right? So we are getting the chunks of these indexes. Okay, because the chunks and the embeddings are gonna have the same length. Okay, so if I get the max indexes of embeddings, it also means it is the max embedding of chunk. Okay, so that is how this function work. And finally, we'll return the top k chunks. All right. So I'm returning the top 3 chunks. Okay, we'll see what is there. And it has said a lot of things where there are some languages. Yeah, there are my skills and all. But yeah, with a small model, I don't expect to give good result, because this should have been the first one, and probably this as the second and this one as third. It is opposite, but it's fine by me. Okay. So next, what you need to do is you need to provide the input to your LLM, right? So all you need to do is just format the prompt. So for this, we'll stuff the documents together as a single prompt or single string. Okay. So for this, what you need to do is just go through the chunks, and I'm just giving it as document is 2, got some number for the document. Okay. And here you can see it is there, right? Document 1 and the document, and then document 2, document 3, everything will be there. All right. All it will do is it will add the document number to it, and we are just joining it together. Okay, nothing very complicated in here. So once this is done, your relevant docs are ready, but still the model input is not ready. So to give the LLM, we'll be making our own prompt template, where there it was prompt template from template, and you'll provide the input variables and things like that. Here all you need to do is just make a prompt, which I did here. And what we will do is we'll just call the format function. Okay, that's why I said it is very easy. It is a string format. When you see it as prompt template from template, you'll think, okay, man, this is very complicated and stuff like that. But when you do it from yourself, right, this is gonna be very good for you. All right, and it will be easier for you to understand that there is nothing going on behind. So all you need to do is then just have Grok API key, and provide your own API key here. So once that is done, we are just ready with the LLM input, and the LLM name is the parameter here, and we'll also provide the context and question. Okay. Once you provide the context and question to the prompt, which is here, we'll format the prompt to provide the LLM input. We are also creating the LLM here. All you need to do is in Grok, call the .chat.completions.create. This is an API request where the role is user and the content should be your LLM input. Okay. Provide your model name here. And once you provide those, just run it, And all you need to do is just provide your LLM name and then the documents which you retrieve now and your question which already you gave. Okay. And it gave the perfect answer. And I'm pretty happy with what I have achieved in this specific thing. So yeah, guys, and all you need to do is just make this a simple class, just a Python class, and you'll be able to deploy it very easily. And this is how you can create your own custom RAG, and you can add whatever features you want in this by yourself. And if you want to build these kind of things from scratch, for example, metadata retriever or compression retriever, contextual compression retriever, there are a lot of advanced RAG. And if you want to build those from scratch, let me know. We'll make a separate playlist on that and we'll work on it. All right. So yeah, guys, if you all like this video, please hit the like button and share it with your friends. I'll see you on the next video. Until then, cheers.